Hello and welcome to this presentation covering the winter weather climatology across central Virginia, southeastern Virginia, as well as the eastern shore of Maryland. We'll also spend a few minutes just talking about how to best utilize the National Weather Service web pages when winter weather precipitation is in the forecast. My name is Jeff Orrock. I'm the meteorologist in charge here at the National Weather Service office in Wakefield, Virginia. The climatology that you're about to see was prepared by Larry Brown, a senior forecaster here at the National Weather Service office and also our climate focal point. When looking at the average temperatures for both Richmond and Norfolk, you notice that during the winter months, December, January, and February, our average high is about 47 to 50 degrees, while our average low in Richmond runs from about 28 degrees to about 30 degrees. At Norfolk, the average high temperature is as cold as 49 degrees in the month of January, with the average low temperatures right around or just above freezing. Keep in mind that any time snow and ice are in the forecast, in order to experience a snow or ice event, temperatures have to remain below average. So it's only during below average episodes where we have cold temperatures is typically when we may experience our snow and ice events. The average snowfall from 1949 to 1950 to present across the area varies quite a bit. The average snowfall ranges from about 5 inches across northeastern North Carolina to 7 inches in Norfolk, about 11 to 13 inches by the time we get into the corridor from Salisbury, Maryland to Richmond, Virginia. As you move further west towards Farmville, the average snowfall is around 14 inches and upwards of 18 inches as you get far northwest as Louisa. The main concern when we talk about average snowfall is that the average is really just an average of extremes. There's very few years where each location actually experiences the average amount of snowfall. So let's look at this just a little bit to address some of the variability. Taking a closer look, what you see here in the upper left-hand corner for Norfolk, the dashed line is the average snowfall amount, where the solid line is what we call the median. And if you notice at Norfolk as well as Richmond, the solid line, the median amount of snow, falls well below the average amount of snowfall. The same thing is true for both Richmond and Norfolk. If you just look at the 1950 to present at both Richmond and Norfolk here at the bottom, again, you can see the variability from year to year of snowfall, where you see some years where the precipitation amount of snowfall has been very high, and other years where has been very little to almost no snowfall. And again, this is evident at both Norfolk here on the left, as well as Richmond here on the right. Taking a little bit closer look at this when we talk about the climatological norm, you do notice that there's some pretty high peaks here. This is the example for Norfolk, where you're seeing some very high amounts of snowfall, where other years the snowfall is almost non-existent. When we talk about average snowfall, it's really the average of these extremes that give us our average snowfall for the year. For climatology purposes, we really use data from about 1950 to about 2010, which is the area highlighted here in blue. Median snowfall, if you look at the second bullet, represents 50% above and 50% below what is actually being observed. So you're basically getting the median, what is the absolute middle of all the observations, not just the average. So the median is a better way to look at snowfall accumulation versus just saying the average. The difference here at Norfolk, the average snowfall is 8.1 inches, but yet the median is 5.8. So again, the median is more realistic of what we would expect to be quote-unquote normal snowfall. Looking at the database from 1950 on, you'll notice that the long-term average decreases from 8.1 for all the climate data. From 1950 on, you notice the average for snowfall actually goes down a little bit. The median also drops just slightly from 5.8 to about 5.1. So this would suggest that since about 1950, we've taken out a few of these other extremes, and so the median and average have actually come down a little bit since 1950. At Norfolk, out of 121 seasons, 78, or roughly 64%, have below normal snowfall. So this would tell you on an average, most years you can expect to experience below normal snowfall at Norfolk. As far as when we typically see snow across our forecast area, here in Louisa, you can really see the black line here represents the chances of any snowfall accumulation. Basically, as long as you have enough snow that you can measure, that's what the black line represents. So when do we expect snow that will fall that may actually accumulate? You do notice an uptick here in the probabilities in December, but really our best chances for snowfall accumulation are really January and in through most of February, even into early March. But you notice here by about the first week of March, or shortly after the first week of March, the chances for accumulating snowfall drop dramatically. Doesn't mean we won't see a snowfall event. It just means the odds of getting accumulating snow start to decrease dramatically. And of course, this is due to an increase of hours of sunlight, and the daily temperature starts to increase as well. Salisbury, Maryland, you see much of the same trend with an uptick in December, with the peak months for snowfall accumulation really again being January and February, with a sharp decrease in March. Richmond shows the exact same climate signal, with an increase in December and the maximum really occurring in January into early February, with a slight decrease by the time we get into late February, and of course by mid-March the probabilities have decreased dramatically. Norfolk is much the same, with a slight bump here in December. Primary chances for snowfall occurring in January into about February, and by the time we get into late February, you're already starting to see the chances for accumulating snow decreasing, and by mid-March the probabilities have decreased dramatically. Again, this is based off of climatological norms, and the area has seen some big snowfall events in December and all the way through early March. Now I'll take just a few minutes to talk about our website and how to best utilize some of the National Weather Service resources anytime snow and ice is in the forecast. This is the main National Weather Service interface, known as weather.gov or weather.gov. All the maps that you see on the web pages are interactive. To get to the local forecast for the Central Virginia, Northeast North Carolina, and Maryland, just come to the map and click on Central Virginia. This will take you to the National Weather Service office forecast here in Wakefield, Virginia. This is a fairly new interface that is still under development, so please feel free to provide comments on this interface. Our old original web pages are still active, and while you can use this website here, and also you can utilize some of these drop-down menus to access various products, here at the very top of our website, under our news headlines, you can still access the old original National Weather Service Wakefield website. So you click on that link, and this takes you to the website that most folks are familiar with. The easiest way to obtain forecast information as well as the weather conditions for your area is to just interact with the map. If I'm interested in the forecast in Richmond, I can just click on the map here at Richmond, Virginia, and it will take me to the local website for the forecast for Richmond. At the top, you'll see the current conditions here in Richmond, 65 degrees, as well as the humidity, wind speed, dew point, and visibility. If there was any snow falling, you'd actually also see reports of snow and precipitation if it was rain. You can get 3 days worth of weather observations here under 3-day history. You can also click on more local weather to get some surrounding observations from around the Richmond metro area. As you go down to the page, you see a quick week at a glance, so you can see a 20% chance of showers in this example for this afternoon, with an increase up to 50% chance tonight. Again, if snow and ice were in the forecast, you would see chances for snow and ice in the forecast here. The daily high-lows are also listed here just as a quick glance. A more detailed forecast is provided here underneath the icons, where you actually get a more detailed 7-day forecast that runs out the entire week. If there were any watches and warnings in effect for the region, they would actually show up here right above the 7-day forecast. You would see in big bold red winter storm warning, freezing rain warning, high wind warning, wind chill advisory, whatever it might be. It'll show up here right above the top of the forecast, and also be an interactive link taking you to that product so you could get the details. Over here, you notice a map that shows you the location where you clicked. So the forecast is for this point in Richmond. You can zoom the map in and out. The map is also navigable, so I can come up here. If I decide I want the forecast up here around Mechanicsville, I can click in the area over Mechanicsville, and the web page will update. And again, now you see that I've clicked the map near Mechanicsville. Again, the map is interactive, so you can zoom pretty far out and start to move around to try and get forecasts for different locations. Above this map, you will notice the last time that the forecast was updated. So for this example, the forecast was updated around noon, and of course this was on December 10th. The forecast discussion is an excellent link. It's right here, located right above the map here. Click on the forecast discussion, and this will take you to the reasoning behind the forecast. This is a product that the forecasters will issue 4 times a day. It's broken up into different sections. Here's the near-term section, talking about the forecast through tonight. You scroll on down, you'll see the short-term section, which in this example covers Tuesday through Thursday, and then the long-term that covers Thursday night through Sunday. The forecast discussion covers all 7 days of the forecast and is an explanation behind why we're forecasting what we're forecasting. Back on our forecast page for the Richmond and Mechanicsville area, continue to scroll down the page and you'll see a link to the radar and satellite imagery, which we will not cover here. You'll also see a link to the hourly weather graph. This is a very useful product when trying to plan for snow and ice. Clicking on the hourly weather graph will give you an hour-by-hour forecast of temperatures in red, wind direction and wind speed here on the second row, The brown line represents the chance of precipitation. So you can see here a 20% chance of precipitation this afternoon, going up to a 50% chance of precipitation tonight, and then back down to 10% by tomorrow. The blue line can be useful and represents the percent sky cover. So here you see the blue line being almost 100% today and tonight, which means complete cloudiness. And then by tomorrow you see the sky cover getting down to 48%, which means the sun will start to shine through, maybe half clouds, half sun. Obviously, the more sun that we see following a snow event, the more rapid melting we'll experience with snow and ice. You can turn off some of these elements if you're not interested. For example, I can turn off the dew point. I can turn off the relative humidity to kind of make things a little bit less busy, and I can resubmit the forecast, and it will clean up the graphs a bit. Notice how the green line for dew point has disappeared, and also the line here that was showing relative humidity has also disappeared. Now, once I use the look at the precipitation potential, I can continue to scroll down the hourly weather graph and try to figure out exactly what is forecast to fall. In this example, only rainfall is predicted. If there was thunder in the forecast, you would see some red bars here as well. Same thing with snow, freezing rain, and sleet. If we were expecting snowfall, you would see some blue bars here in the forecast. Freezing rain would show up as purple, and then in orange would be any periods of sleet that we may be forecasting. So this is a great tool to try and anticipate when the forecasters think the types of precipitation will change. When will we change from rain to snow? How long will it snow? How long will we experience freezing rain? So this is a great product for timing. Now, the hourly weather graph only shows about 2 days at a time, so if I'm interested in looking at the forecast about 3 or 4 days from now, just come over here and click forward 2 days, and that will jump the forecast ahead 2 days. So now I'm looking at the forecast more for the middle to the end of this week. You can also set your start time. If I'm interested in starting the forecast at a certain time, I can come here and say I want to start my forecast. At this example, I want to start my forecast at 12 a.m. Thursday. I will hit select, and then resubmit the forecast. And now here your hourly weather graph will start at midnight Thursday morning and then run out for 2 days. And again, the hourly weather graph is available through the entire 7-day period. And again, all this was accessible from the main forecast interface here on the National Weather Service web pages. Going back to the main Weather Service website, back here at the Wakefield Weather Service Office webpage, another great resource when trying to anticipate snow and ice is to go to the rain and snow precipitation link. When I click on this below the map, this will take me directly to the snow and rainfall predictions that we're putting out every day. It defaults to precipitation. This would actually be the liquid equivalent or rainfall that is expected. I can also change it over here to my winter weather graphics. Winter weather graphics would be any kind of forecast snow and ice. In this example here, you see there's no snow being predicted, but you can see here's the storm total snow, and I can get forecasts for snowfall every 6 hours. And again, we do this through 48 hours, and then we also have a storm total. Same thing with ice as well, with predicted ice accumulation. Over here on the right is the national outlooks, the probability of experiencing 4 or more inches of snow, probability of 8 inches or more in the first day of the forecast, and the probability of 12 inches or more. Again, these probabilities also extend out to day 2 and day 3, where you see probabilities of 4, 8, and 12 inches of snowfall accumulation. Another great interface that's accessible from our main Wakefield National Weather Service webpage is also the briefing interface. You can click on the briefing webpage. The briefing webpage is designed to be a one-stop shop for all hazards affecting Virginia, North Carolina, and Maryland. Across the top here, again, you'll see a tab here for rain and snow forecast. This will take you to the same images you saw earlier, where you can see the rainfall forecast through 3 days, and also the snow and ice forecast that extend out through about 2 days. Storm total snowfall as well as storm total ice. Storm total ice is the same as freezing rain. So as you can see, there's a lot of great resources on the National Weather Service webpage. Just remember weather.gov and click on Central Virginia, and that'll take you to the Wakefield National Weather Service office. As always, we welcome feedback on the pages, or if you have questions about how to find resources, you can always feel free to email us. At the bottom of the website, you will see a link here to email the webmaster. The email will come directly to our office, and we can actually reply to your emails and also address any needs or concerns that you may find with the website. You can also follow us on Facebook, so feel free to check on and sign on to our Facebook page. During winter storms, any kind of hazardous weather, we'll be posting updates to our Facebook page. Once again, my name is Jeff Orrock, and I appreciate the time today, and I hope you've learned something about how to best utilize the National Weather Service resources.